This is Engineer Faisal Ijaz. Hope you will be fine. In this channel, I prepared detailed lectures for chemical engineers and also for associate engineers. In this channel, you will find playlists of different engineering subjects which will help you in your study, in your interviews and also during your professional industrial life. So subscribe my channel for more videos. This is Engineer Faisal Ijaz. Hope you will be fine. In this video, we will discuss production process of aluminium. That production process is bare process. So we will discuss that process with the help of process diagrams. But first of all, I will summarize aluminium deposits overlooked in the world. Hope its introduction will be helpful for students in their exams and during job interviews. Here you can see about bauxite. So bauxite is a raw material of aluminium. Before proceeding, take a broader look of that bauxite reserves in all over the world. You can see the countries and percentages of bauxite reserves. So blue part of circle indicating country Guinea, which have 24% highest percentage of bauxite in the world, and if you proceed clockwise in the circle, the deposits percentages are decreasing. In this chart, you can see the quantity of bauxite reserves, and the Guinea have 7,000 million tons of bauxite in the world. So the aluminium metal has some special properties. So it's a popular metal. So in these properties, the first is light in weight, it's anti-corrosion, high strength, conductivity, good ductility, beautiful appearance, and 100% recyclable. So 77% of bauxite used in these four branches: modern construction, automobile and transportation, packaging materials, and electronic products. We take an overlook of aluminium deposits in Pakistan. Bauxite is present in all provinces of Pakistan, but its main source is in Punjab district Khoshab in an affiliated valley which is called Soon Valley, and the location of these deposits are near Ziyarat Pir Sultan Mehdi. You can see the picture of that Ziyarat. In this chart, you can see all the mineral deposits which are located in Punjab, and at second number, bauxite is also available. Bare process. It is an industrial process in which pure aluminium extracted from its ore, which is bauxite. So that raw bauxite contain 30 to 35% hydrated aluminium oxide. So it's mean that ore have moisture in it. Bare process. It is an industrial process in which pure aluminium extracted from its ore, which is called bauxite. So that raw bauxite contain 30 to 50% of hydrated aluminium oxide. So you can see it's aluminium oxide in this picture, but the word hydrated shows that it has moisture in it. So here we will say hydrated aluminium oxide. So that moisture is not locked in crystal structure. In aluminium oxide, water exists in form of hydroxyl radical. So before proceeding, I will tell you what is hydroxyl radical. What is the difference between OH negative and OH radical? So the neutral form is known as hydroxyl radical, but single charged hydroxyl anion is called hydroxide. So here you can see the difference of charge. Neutral form is called hydroxyl radical, which is present in aluminium oxide. Before bare process, raw bauxite present in the form of lumps which are crushed and grind to reduce the size till 0.6 inches, or in millimeter it's 1.5 millimeter. You can see it is a bauxite crusher. At top, bauxite bins are provided. These large vessels are called bins, and in industrial language, bins are just large storage vessels. In this case, bins are at top of crushers, so through feeders a controlled quantity of bauxite ore is coming into crushers where big lumps size reduction take place. So in this case, these bins are provided at top of these crushers, and with the help of feeders a controlled quantity of bauxite lumps is coming into these crushers. So here size reduction will take place. So in this diagram you can see these are bauxite surge bins. It's mean these are storage vessels, and the next one are feeders through which controlled quantity is coming into crushers, and these are crushers which reduce the size of that ore. So next section is grinding section, where grinding mills are provided, and two mills are included in this section. The first one is rod mill and the second one is ball mill. So in rod mills the heavy metallic rods are provided, and in ball mills heavy metallic balls are provided, and these mills and rods are free in cylindrical vessel. So when we rotate the drum, so these balls and rods also move with the wall of that drum, and at top they fall with gravity on the coarse size material of bauxite and convert into a small or powder shape bauxite material. In the next step, we prepare bauxite slurry. So before proceeding, I will tell you what is slurry. Slurry is a term used in industry which means watery mixture of insoluble matter. So here we prepare slurry of two things. The first one is sodium hydroxide, which is also called caustic soda, and the second one is grinded ore. So we form bauxite slurry in this section. In this diagram you can see four tanks which are provided with an agitator in center to mix the mixture of water and bauxite. Now the slurry is ready for further proceedings. After preparation of slurry, we will use four different steps to get pure aluminium metal. So the first one is digestion, the next one is clarification, then precipitation and calcination. First of all, we will discuss digestion process. So digestion process take place in a big vessel called digester, or also called autoclave. So in this process, two type of feeds are entered into that vessel. The first one is bauxite slurry, which is present in storage holding tanks, and the second one is hot concentrated caustic soda liquor. So these both feeds are mixed with each other, and here maximum concentration of alumina dissolved into caustic soda liquor solution. In this diagram you can see left side a circle and that is also indicating a digester. So two type of variables are labeled here. The first one is temperature, and that digester work at 310 centigrade temperature and also at 5200 kPa pressure. So after digestion the material go for further proceedings. Next step is clarification, which is a separation or purification step in which we separate alumina. And you know well that bauxite contain different components like calcium oxide, iron oxide and titanium oxide. So except alumina and silica, other components do not dissolve into caustic soda liquor. All the mixture in this drum having a reddish color mud and the impurities also settle down at the bottom of that drum, which is called thickener and also called settlers or clarification tanks. So the next section is precipitation, in which we recover crystals of aluminium hydroxide. After removing the impurities in previous section, we get clear liquid which is pumped from settlers to precipitators, and these precipitators are also called thickening tanks. During transfer of a clear liquor from settler to precipitator, we use heat exchanger in between these two equipments to transfer heat from solution to the cold spent liquor. To improve the precipitation of aluminium hydroxide is promoted by a process which is called seeding. Seeding is a process in which we provide pure alumina crystals, and these crystals act as a nuclei for the precipitation process. So during precipitation process, we get two types of particles. The first one are coarser particles, which are larger particles, and the second are finer particles. So in the form of these two particles, we extract 90% aluminum hydrate from this liquor. So the coarser particles are used for calcination process in further proceedings, and these finer particles are used for seeding process. So next section is calcination process, in which aluminium hydrate crystals are washed, dried and heated at temperature 1010 to 1260 centigrade. So to remove the moisture of these particles, we use retriculums or fluidized bed calciners to remove these moistures. So here you can see what happened at different ranges of temperature. At 400 to 600 centigrade temperature, we got gamma form of Al2O3, and after 1150 centigrade, that gamma alumina transform into alpha alumina, which is chemically inert. So our final product is dry white anhydrous alumina powder of particle size 0.5 to 10 micrometer. During calcination of alumina, the main impurity we got is sodium oxide, which have different concentration in between 300 to 7000 ppm.